Winter has arrived, the winter solstice passed, marking the official start of the season. We want to thank you for joining us on this special edition of Weather Out West, Winter Out West. I'm your host, meteorologist Ashley Ruiz. One of the first things that comes to mind during this time is snow, of course, an iconic part of the season, and snow is more than just a winter wonderland for skiers and snowboarders, but a vital resource for our ecosystem. Portland's meteorologist Rod Hill has a closer look at the snowpack in Oregon.
I'm meteorologist Rod Hill talking about the Cascade snowpack and specifically around Mount Hood here in Oregon, which we are seeing changes to due to a warming climate. In fact, one of the big stories so far this early winter season is a lack of snow. Now, we've had some snow at Timberline, but what has come has been going, and we just haven't picked up enough to really get our resorts open yet. So it's interesting that that is a big story as I bring up this warming topic. So I do want to show you, this is not Mount Hood, but this is site specific to Portland. But though it tells the good story of warming climate. If you compare what the 30-year averages of temperatures were back in 1971 to 2000 to our current 30-year average, we have warmed in Portland for the month of September by 2 full degrees. October a degree, November 2, December 1.5 inches. And throughout the winter season, these are all warming numbers, generally 1 to 2 degrees. And absolutely numbers are warming on Mount Hood, which leads, of course, to a higher snowpack, as I'm sure you realize. This is interesting. Mount Hood snowpack, SWE is stored water equivalency. So basically when you melt the snow, it's how much water you would have stored in the snowpack. And what I want to point out here, this is what's considered 100% of normal snowpack. We bounced above 100% every now and then through the year 2011, but since then, it's become increasingly difficult to get up to 100%. Yeah, here's a very vivid snapshot. Sticking with the stored water of the snowpack. Now, historically, we've measured this for the season, April 30, May 1, when the snow season ends. That makes sense. So from 1971 to 2000, the stored water melted down to 65 inches. 81 to 210 at only 62 inches, and then down to 57. And if you just go for the last 20 years or so, it's all the way down to 48 inches. So that is a vivid snapshot. It's not just Mount Hood. Here's Crater Lake, snow 1931 to 2005. And again, notice a lot of years, big years above normal, not as many above normal here recently. These atmospheric rivers potentially are part of the issue because they typically come in with high snow levels and warm weather. There has been talk of seeing increasing atmospheric rivers. Most of the research I've seen pointing to the bigger trend will simply be the atmospheric rivers tend to go to the north. So it might be a while before we see the impact of that. But warming weather on the mountain, absolutely a growing issue.
Several cities in the West have already had their first snowfall of the year. You've heard the saying, no two snowflakes are alike, but have you ever wondered why? Seattle's meteorologist Leah Pizzetti explains the science behind how they're made.
We know snow forms when you have moisture at freezing temperatures, but let's go beyond that. Within every snowball, you have snowflakes, and these are tiny, tiny, fascinating specimens.
Take a closer look at the snow falling around you. Individual snowflakes reveal a clear shape created in special circumstances.
To get the growth of a snowflake, you need to have nucleation.
That's a fancy way of saying it's crystal formation, says Northwest Avalanche Center meteorologist Robert Hahn. Snowflakes form when water droplets attach to particles in the sky, like dust or pollen, creating a six-sided shape. They then fall, dropping through different types of air, giving them each a unique appearance.
No two snowflakes have the exact same journey through the various temperature and pressure regimes.
For that reason, no two snowflakes look the same, just like a thumbprint. The atmosphere they fall through changes the shape they become.
Is it forming lengthy hexagonal columns, or is it forming more flattened plates?
Warmer temperatures tend to lead to longer shapes, like a needle. Colder temperatures create flat, plate-like snowflakes. Robert says the type of snowflake can even impact avalanche risk. If the snowflakes are too cold and fall too fast, they don't bond together quickly enough, creating a weak layer of snow, and that is one of the factors that can lead to an avalanche.
So the next time you see snowfall, take a closer look. See if you can make out the 6 sides of a tiny crystal and know that the snowflake you're holding is unlike any other out there. For Environment Northwest, I'm meteorologist Leah Pizzetti.
And when those flakes fall, they have different ways of accumulating. Some systems bring us wet and slushy snow, and others light and fluffy snow. Spokane's chief meteorologist Jeremy Legoo breaks down the science behind snow.
Ask any snow lover and they'll tell you, not all snow is created equal. There's fluffy snow and snowball snow, powder, sugar, slush, ice, and that's just scratching the surface. Thankfully, we have a way to quantify the different types of snow. We call it a snow ratio, or more specifically, a snow to water ratio. It's actually quite simple. If you take a given amount of snow and melt it down, how much water do you get? So the bigger the number, the fluffier the snow. It's how many inches of snow you have to melt to get 1 inch of water. An average snowfall gives us about a 10 to 1 inch ratio, or 1 inch of water in every 10 inches of snow. If it's warmer, the snow is wetter and heavier, and that number drops. A 5 to 1 is a wet snow, perfect for snowballs or snowmen. If it's colder, the snow is fluffier. At around 20 degrees or so, the ratio jumps to a 20 to 1, and we skiers call that blow or pow. It's the kind of snow you can clear from your driveway with something like a leaf blower. Wind and humidity also play a role in snow ratios. Think of it this way. Snowflakes are fragile. A strong wind can send them tumbling through the air. As they fall, the crystals break off, meaning they can pack together more densely when they hit the ground. Likewise, the amount of moisture in the air can also change how those snowflakes form, eventually impacting how they settle together on the ground. The snow ratio is useful beyond measuring the snow that falls from the sky. Each winter, we measure the snow on the ground using SWE, or snow water equivalent. We have stations in the mountains all across the western U.S. that measure snowpack using snow water equivalent, or how much water is frozen in all of that mountain snow. It is our best way to keep track of where we stand each winter in terms of snow and accurately compare it to years past. It also lets us know how much water will fill our rivers, lakes, and reservoirs as it melts in the spring and summer months. Often, one of our earliest warning signs of an emerging drought. For KREM 2 News, I'm Chief Meteorologist Jeremy Legoo.
Snow is not the only thing that will be falling from the sky this winter. Atmospheric rivers are very common during this time. We'll have an explainer on what those are next. Plus, the holiday season is one of the busiest travel times of the year. The winter conditions you need to know as you make plans to head out the door. This year, we saw major impacts in both Washington and Oregon from multiple atmospheric rivers. Those systems gave us massive amounts of water vapor, and while they can be crucial for our water supply, they also brought devastating flooding to the Pacific Northwest. Seattle's senior meteorologist Rich Marriott dives into more about this common winter phenomenon.
Well, December 2025 is probably going to be remembered for all of the flooding and the massive amounts of water that came out of the sky early in the month as atmospheric rivers took target on the Pacific Northwest and kept aiming at us all the way through. This is on December 8th, just as it all got underway. This atmospheric river, perhaps one of the longest that's ever been seen in the Pacific, stretched all the way from the Pacific Northwest, crossed the Pacific, went north of Hawaii, and ended up probably somewhere near the Philippines. And that was basically a pipeline bringing warm air and amazing amounts of water all the way to the Pacific Northwest. We saw major flooding on multiple rivers. We had quite a few rivers that had historic water levels in them, and that continued on pretty much for that 10-day period. We had periods in there where we had 2-3 days at a time where we get as much as 15 inches of rain up in the Cascades, and just amazing amounts of water that came down. That continued on with a number of atmospheric rivers moving through here all the way until December the 18th, when the last one finally dragged through just to the south of Washington through Oregon, and that dropped southward, bringing in some cooler air from off the Gulf of Alaska, and finally improved conditions. But interestingly enough, as massive as this event was, you probably haven't heard the term atmospheric rivers until the last few years.
Atmospheric river may sound like something new, but it's really just another name for the Pineapple Express. This is what we used to call the drenching warm rains that flow from just to the north of Hawaii. It turns out that the Pineapple Express is just one type of atmospheric river. Researchers in the 1990s determined that these narrow bands of moisture over the oceans constantly transport huge amounts of water from the tropics to the mid-latitudes where we live. These plumes of water vapor are narrow, usually only several hundred miles wide, but thousands of miles long, resembling a river in the sky. And these rivers are low in the atmosphere, generally less than 2 miles in depth, far below where jetliners fly. Despite being narrow, they carry unbelievable amounts of water. The largest atmospheric rivers may carry the equivalent of 2 Amazon rivers, almost 10 trillion gallons of water per day. Most of this water vapor stays in the clouds until it collides with land, like our west coast. Since all this water is low in the atmosphere, it's forced up over the mountains, and in the process, much of that water is dropped on the west-facing slopes. The most destructive atmospheric rivers are those that stall over one area and persist for days. These are the ones that can dump feet of rainfall and cause massive flooding and widespread landslides. However, weaker atmospheric rivers are important to our water supply. 30 to 50% of West Coast rainfall comes from atmospheric rivers.
This time of year, drivers in Washington would usually be using Highway 2 to get to the slopes at Stevens Pass or the town of Leavenworth. But a landslide triggered by the atmospheric river took out the roadway. Seattle's Bridget Chavez shows us the impact of this major ongoing closure.
We're here on Highway 2 near Leavenworth, and this right here is what crews are dealing with. The road here just completely gave way underneath it. So this is why this area is closed off.
The destruction is impossible to miss.
You kind of don't really believe it until you see it.
This section of Highway 2 washed out and collapsed, now sitting in the Wenatchee River.
This is not AI, this is real.
This failure is part of a 49-mile closure between Skykomish and Leavenworth, cutting off one of Washington's most important mountain routes. And it's not a short closure. Governor Bob Ferguson says repairs could take months.
This is a pain.
We were only able to get this close with an escort from the Chelan County Sheriff's Office.
We have a lot of work ahead of us here in Chelan County.
Officials say the ground here is still shifting and are warning people not to go around the barriers.
No, you don't need to come down US 2. You're not going to make it through US 2.
What looks stable can give way without warning.
What we're seeing is this is unique to Chelan County. You look at historical floods, and it's been one of those years.
And this isn't just a road problem, it's also a business problem.
Well, it's challenging. I mean, there is definitely people that come over Stevens Pass to visit us here at the park and in Leavenworth in general.
For businesses in Leavenworth, Highway 2 is one of 2 ways to get here from the west side.
They still have Blewett Pass they can get over, and most people do. So I'm hoping that they'll do that.
Over the years, there have been weather-related closures, but usually a few hours or days. This is different. State officials say parts of the road need to be rebuilt, not just reopened.
I think that's going to be a challenge. I don't think in my history here I've never had this happen before.
Again, just to reiterate, we were escorted out here by the Sheriff's Office. Officials say do not go around these barriers because this entire area is unstable. They're worried about even more slides coming as the rain and snow come falling down. Reporting near Leavenworth, Bridget Chavez, King 5 News.
Driving isn't the only way people are traveling for the holidays, and it certainly isn't the only travel affected by winter weather. Coming up, the conditions that can make flying tricky, and a look at the forecast for what you can generally expect in the months ahead. A La Niña is in place. We'll explain what that actually means next. Winter weather can create serious challenges for travelers, as we well know. Strong winds and icy tarmacs are often behind flight delays and cancellations this time of year. Hector Mendoza and Audrielle Tackett from our station in Boise show us what conditions are most likely to disrupt air travel.
Winter weather doesn't have to be extreme to have disruptions on air travel. In southern Idaho, wind and ice are two phenomena that have major impacts at the Boise airport.
Winds vary city to city in the Boise metro and can be very strong at times. Winds can ramp up quickly with a cold front passing, when storm cells create outflow winds, or when a strong pressure gradient develops. Pressure gradient is the difference between air moving between high and low pressure. The steeper the pressure difference, the stronger the winds. In any scenario, gusts could reach up to 50 miles per hour. Strong winds can make takeoffs and landings difficult, slow ground operations, and delay or cancel flights. Another occurrence, icy airport tarmacs. They develop when snow, rain, or cold, damp air freezes on surfaces, making runways and taxiways slick for aircraft. Compact ice can also form when snow melts and refreezes. That could require repeated de-icing and anti-icing efforts. In Boise, about 75% of winter precipitation falls overnight, often leading to icy conditions for morning travel. Icy tarmacs can delay operations, require planes to get additional treatment before takeoff, or cause cancellations.
Audrielle mentioned icy conditions and strong winds, but fog, rain, and snow are also major obstacles for air travel across Idaho, especially in southern Idaho and the Treasure Valley. Fog is one of the most disruptive conditions, severely reducing visibility for pilots during takeoff and landing, and often slowing airport operations or grounding flights. Snow adds another layer of difficulty, covering runways in ice and slush and reducing braking ability. Crews must plow runways and de-ice aircrafts, a time-consuming process that frequently leads to delays and cancellations. Heavy rain can also create slick runway conditions, while freezing rain is especially dangerous, forming ice almost instantly on aircrafts and airport surfaces. Even with advanced landing technology at the Boise airport, these weather conditions force slower operations, ground delays, and flight cancellations, impacting not just local flights, but air travel across the region. Outages involving FAA navigational aids are also a concern and pose issues to air travel. And even when the weather is clear in Idaho, flights can still be affected. Storms in other parts of the region, like the Pacific Northwest or along major flight routes, can cause cascading delays that impact arrivals and departures at Idaho airports. Together, fog, rain, and snow continue to disrupt air travel statewide, affecting both local and regional flights.
Each year, scientists look at ocean temperatures thousands of miles away from the Pacific Northwest that impact weather worldwide. These patterns can prompt an El Niño or La Niña season, trends which can last anywhere from about 9 months to multiple years.
Because water holds so much heat than air, that has consequences all across the globe for temperatures and other weather effects.
Along the equator, trade winds push water east and west. During an El Niño pattern, the trade winds weaken and warm water stays east, collecting off the coast of Peru. This impacts the jet stream, which is essentially a pathway for storms to move over the United States. The warm water pushes the jet stream south, driving storms into the southwest parts of the country, but keeping the northwest warmer and typically drier. La Niña is the opposite. Trade winds along the equator strengthen, pushing warm ocean water away from Peru to be replaced by cold water. This pushes the jet stream more north, keeping the southwest more dry and the northwest more cool and possibly more wet. While none of this is a guarantee, Washington State climatologist Guillaume Mauger says it's our best guess at a general trend, giving an idea of what could happen in the winter.
What the La Niña is going to do is going to tilt the odds, right? So that means the odds are tilted towards cooler than normal conditions.
Since 1954, there have been 25 La Niña patterns, and just 7 of those were considered strong. Within those 25 La Niña winters, 14 brought below normal temperatures, with the average temperature nearly 2 degrees cooler than normal. Precipitation had more variability, with a split of about half above and half below normal. Seattle's snow totals have historically been higher than average during La Niña winters. Normal is about 5 inches, but the 25 La Niña winters averaged 11.5 inches. This potentially good news as the Northwest comes out of a warmer and drier drier weather pattern.
The other thing that we could look for, and that's kind of interesting, is that we're going from an El Nino to a La Nina. So there's a real contrast between last year and this coming year, right? It's going from warmer to cooler.
Now that you know what a La Nina is, we'll give you the forecast and what it could bring this winter coming up after the break. And winter in the Pacific Northwest can mean more than just rain. Ahead, the powerful windstorms they can experience. I want to thank you again for joining us for our special Winter Out West. We're taking a look at weather trends around the western United States. And in this last half hour, we told you the difference between a La Nina winter and an El Nino winter. Seattle's meteorologist Adam Claiborne shows us what we can expect this winter season.
Hey there everyone, I'm King 5 meteorologist Adam Claiborne, and it's been a very interesting and wet November and December. Now as we start off winter, we are looking at a pretty interesting pattern. Now I was actually talking with meteorologist Rich Marriott about this. Check out what's happening behind me. You can see kind of the horizontal orientation of the colors between the purples all the way down to the reds, and this is what we call more horizontal flow, meaning that you get a progressive pattern as systems move more so from the west to the east. And that's what we've been noticing here over the past month and a half, is that systems have been really moving more so west to east. And if that storm track is right over you, like some of us here in the Pacific Northwest have been seeing, you get quite a bit of rain. Now, yeah, there is a bit of a change as we head on into the latter part, heading into more the latter part of December, but we're going to talk about that in a second. Again, with that storm track more so over certain parts of the country, like here across the Pacific Northwest, Seattle, you can see things were not looking the greatest beforehand when we were seeing a lot of severe and extreme drought across the state. But that was late October. This is how it looks right now in mid to late December. And you can see a lot of that drought has been erased. And just a little moderate drought here west of the Cascades. The yellow pops up with abnormally dry soil, which is not technically drought, but it's either saying you're going in or you're coming out of drought conditions, which in this case, we're talking about a lot of spots which will be coming out of drought conditions with more of that wet weather to come. Now, the wet weather and the wetter than normal conditions, pretty typical for a La Nina season. Typically, that will produce a higher chance of seeing colder and wetter than normal conditions. And yeah, it's been wetter than normal, but not really colder than normal. But here we are looking at the Pacific North American Index, and that is showing that we could start to see some changes. Anytime that you see that on the negative side, that means you start to see a little more troughing. And when I showed you that dip in the jet stream that's heading down to California, that's helping to produce a bit more of that active weather. And that's going to bring in colder weather across more of the state of Washington, meaning better chances of seeing higher amounts of snow across the Cascades. Now, this is just model data. It doesn't mean that we're exactly going to see these amounts, but it does show that the pattern is going to be around for us to see better chances of mountain snow. And with the Climate Prediction Center kind of indicating that we should see things staying wetter than normal here across the Pacific Northwest, as well as staying cooler than normal across the same area. Looks like skiers and snowboarders are going to be very happy with what happens here over the next 2 to 3 months.
I'm meteorologist Monica Woods looking at our past water year, wrapping up with a very distinct line of a very wet Northern California and dry Southern California. Our water year begins on October 1st, ends the following year, September 30th. Here's how it played out over the following 2024-25 year. Long duration atmospheric river hit Northern California at the end of November. Multiple weak atmospheric rivers then lined up in December leading into January. But that dry Southern California led to those LA fires with multiple atmospherics after that. That left us with about 96% of average for our snowpack. And it was good storage because then we head into the heat and the time when we have our water at its highest demand throughout the state. Sierra's snow water equivalent, it is a critical number for us as we store a lot of the melting snow into our reservoirs. And we ended up anywhere from 82 to 118% of average, giving our statewide average, like I said, about 96 to 97% of average, depending on how you want to round those numbers. A look at our reservoir storage peak. By June 1st, after all that snow melted, we were well above average, anywhere from 109% to 127% of average. So the capacity, some of those reservoirs were just about as full as they could get. In fact, Oroville actually reached 100% of capacity. We have hundreds upon hundreds of reservoirs and dams throughout the state. Some are federally owned, some are state. All of this feeds the entire population with water during what tends to be about 6 to 8 months of complete dryness throughout the state. So our California water conveyance system, a really critical one. All that water that generally falls north of that I-80 line in Northern California is released, and it moves through the Delta area, then into the California aqueduct. Now that runs roughly from about Central California all the way into Southern California. So especially for a northern part of the state that received most of the rain, that was really good news. Like I said, multiple things go into the equation, and we've had 2 to 3 years of really good atmospheric rivers coming through the state, filling the reservoirs, helping to saturate our soils, especially for Northern California. And when you look at the difference it makes in our drought monitor in 2022, we had growing drought with multiple atmospheric rivers and good water years. That shrunk and is continuing as we're heading into this year.
It's one of winter's most dangerous road condition, black ice. Almost invisible, it can make driving very tricky. Denver's meteorologist Corey Reppenhagen tells us the best way to spot it.
Hey, it's meteorologist Corey Reppenhagen from the 9 News Weather Impact Team in Denver, Colorado. You know, the winter can be fun, it can be beautiful, but it can also be hazardous on the road. So one thing you should always keep in mind is that the bridges and the overpasses freeze first. So basically what happens is the roadway accumulates heat during the day and gradually radiates that back into the atmosphere at night. And the ground underneath the road helps insulate that. But you can see, I mean, the roads, the bridges, the overpasses, no ground underneath means that twice the cooling can happen. The cool air of winter can cool from the top and also from down below. So twice the cooling results in it cooling down twice as fast. You'll see a big temperature difference between the roadway and the bridges. Another thing that you've got to watch out for is black ice. Wouldn't it be nice if there was just a sign telling you there was black ice? But you've got to identify it yourself, and it's not really black. It's actually a very thin layer of ice, and it is very slippery. It's so thin, in fact, that it's almost transparent, all completely invisible, so it's very hard to spot. So let's play a game. It's called Is It Black Ice? And I took this picture in Denver after our first snowstorm this year. This is Spear Boulevard, one of our main drags. You can see some snow on the roads there. You can see quite a bit of blacktop as well, but look how shiny it is there. This actually turned out to be black ice. Everybody here on Spear Boulevard was slipping around quite a bit. Now take another picture about 4 or 5 blocks down the road. Look at just how glossy and shiny this road surface is. Lots of blacktop. I thought for myself here, this is definitely going to be another patch of black ice. Braced myself, but this was just wet road. So in that spot, the road hadn't had a chance to freeze over yet, or it was some of that liquid de-icer. So you really cannot tell the difference between black ice and wet roads. So the only way to win this game is to treat all those shiny surfaces suspiciously, especially if it's below freezing, and use slower speeds. In case you slip, you can recover. So I hope you all have a real fun, but also a very safe winter.
Here in the Pacific Northwest, we're famous for our rainy seasons, but strong windstorms are another common winter phenomenon. Spokane meteorologist Thomas Patrick shows us what type of weather patterns trigger these gusty conditions.
In the wintertime, it tends to be snowstorms and windstorms that have the biggest impact on the Pacific Northwest. And I want to focus on our windstorms. Sometimes I like to informally call these nor'westers. And funny enough, it does come in 2 different varieties like nor'easters would, or at least that is what I've come to learn and forecast for the Pacific Northwest over the years. There are 2 different varieties of windstorms, and it depends on the storm position and the path that they take. So let's cover how we get windstorms in the Pacific Northwest and those 2 specific varieties that we get. The first one is the coastal version of the windstorms. We look at where the low pressure core of those windstorms are, and in this case, it curls northward along the Pacific Northwest coast. Because of that momentum and that movement, the strongest southerly winds tend to lash out right along western Washington and western Oregon, especially the coastal cities of Washington and Oregon. These kind of windstorms can always give us 70-mile-per-hour winds, and the most recent example comes from last year, the November 2024 bomb cyclone, if you remember, a tightly packed low-pressure region over the Pacific Ocean, moving northward and intensifying, and because of that position, it was 70-mile-per-hour wind speeds and greater that were observed along the Washington coast. Now, that variety of windstorm really only hits far western Washington and far western Oregon. The second variety of windstorms that we get end up moving straight west to east and cuts through British Columbia. These kind of windstorms, same low pressure core, with that momentum, you get strong westerly winds that take advantage of the terrain of both coastal Washington and then the Columbia Basin. Again, same impact, up to 70-mile-per-hour winds expected with some of these windstorms. The most recent example happened just last week, the December 2025 windstorm. In this case, the windstorm via the water vapor imagery cut through that exact path through southern British Columbia, and the strongest wind speeds in Spokane ended up at 75 miles per hour, and we're even above 80 miles per hour for the Palouse region near Pullman. So that's our two variety of windstorms. The first hits the coastal areas, and Seattle ends up getting the strongest winds with the coastal windstorms, and Spokane gets those stronger winds with the ones that cut through British Columbia. So that's our two varieties of windstorms we see through the fall and winter time for the Pacific Northwest.
Ahead, we'll have a closer look at what winters in the desert look like and the unexpected snow squalls that can roll on through. And winter isn't just about the changing weather on land, but the sea has its own phenomenons. We'll show you what's happening on the coast during these months. Winter in the desert is a little different than other regions. Their sunny days can suddenly change shifting conditions quickly. Phoenix's meteorologist Crystal Long shows us a phenomenon that happens there.
I'm meteorologist Crystal Long in Arizona. Wintertime can bring big extremes in our Grand Canyon state. It's not unheard of for Phoenix to pop 80 or even 90 degrees during the winter months. On the flip side, full-blown winter weather can hit the high country. Let me show you what I mean, but make it mixed reality. It's wintertime in Arizona, which for the valley basically just means dining al fresco. But just an hour or two drive up the highway, your sunny skies get wiped away by wicked winter weather. Your trip could turn dangerous in a snap if a snow squall or blizzard blows through, blotting out your view and turning the road ahead into a giant slip and slide. A snow squall is a brief but intense burst of heavy snowfall partnered with powerful winds creating sudden whiteouts. This winter weather whiplash usually lasts just minutes to an hour at most. Because it's so quick, totals are typically an inch or less. It can also flash freeze roads in just a few minutes. But with a blizzard, snow doesn't even have to be falling at all. Snow already on the ground gets scooped up by the whipping winds of more than 35 miles an hour. The blowing snow makes it almost impossible to see, with visibility down to a quarter of a mile or worse. A blizzard will blast for at least 3 hours nonstop. If a snow squall or blizzard warning gets activated in your area, put a pause on your travel plans and stay inside. If you're already stuck out on the road, drop your speed, but try not to slam on your brakes. Turn on your headlights and hazard lights and put more distance between you and the car ahead of you. Flagstaff averages 90 inches of snowfall each season. However, climate predictions are pointing toward a warmer and drier than average winter across Arizona. That doesn't mean we're spared from experiencing an episode of extreme winter weather, though. Every winter, Arizona has to be ready for anything.
From the desert to the ocean, the winter season brings another phenomenon we're tracking: king tides. San Diego's meteorologist Evan Noorani walks us through what they are and what we can expect.
Along Southern California's coastline, the ocean has a rhythm. Most days, tides rise and fall quietly in the background, but a few times each year, that rhythm reaches an extreme. These events are known as king tides, the highest tides of the year, and they offer both a striking sight and a serious preview of future coastal risks. Here's Steffi Roche with more.
There's an old saying, time and tide wait for no man. It's true, but you can catch San Diegans eagerly awaiting the king tides every year.
Just feeling super blessed to be in a place like this, to live so close to nature.
Pragathi Misro tells me her daughters are talking her ear off about the king tides.
My daughters told me about it. They're very obsessed with looking through the tide pools.
King tide events create a dramatic coastline with not only the highest tides, but also the lowest.
It's neat to see it because I don't see all the things that are underneath. And I never knew there's this many rocks and this many tide pools.
Thursday in La Jolla, NOAA reports a just over 7-foot high tide at 7:34 a.m. and a low tide of negative 1.68 feet just before 3 p.m. While high tides occur twice a day, king tides only occur a few times a year when a new or full moon is closest to the Earth during specific seasons.
There's a full moon, so that usually means king tides.
For some, the king tides aren't just about science. Wednesday, I met San Diego natives Brooke Robertson and Giovanni Domini, whose lives seem to align under a full moon, as a previous king tide removed them from the sea of singles.
At the king tide, I actually proposed to Brooke, just over there.
King tides bring exceptionally high tides caused by a stronger than normal gravitational pull from the moon and the sun. So, who knows? Maybe the cosmos will work in your favor, too.
Scientists and planners pay close attention to king tides because they offer a glimpse into the future. As sea levels rise due to climate change, today's king tides could resemble everyday high tides in the decades ahead. For researchers, the tides act as a natural experiment, showing which areas are most vulnerable and where adaptations may be needed. For the public, king tides are both a reminder and a warning. The ocean is changing, and Southern California's iconic coastline is on the front lines. I'm Evan Noorani. Back to you.
We've just passed the winter solstice, the shortest day of the year, and we're already gaining daylight back. But where you live makes a huge difference in how quickly those longer days return. So let's track our 8 western cities from Seattle all the way down to the desert Southwest and watch what happens from December through March. And right after the solstice, gains are subtle everywhere. But when January rolls around, that's when things really start to accelerate and latitude becomes your best friend. Seattle and Spokane gain roughly about an hour of daylight, whereas Portland and Boise less than an hour, but still that's daylight and time added. Sacramento and Denver pick up around 40 to 45 minutes, and Phoenix and San Diego a little more than 30 minutes. But February keeps the momentum going. So Seattle gains about an additional close to an hour, hour and a half, so almost 90 minutes, while Phoenix gains about 50 minutes. That gap keeps widening though. March rolls around, bringing us closer and closer to the spring equinox, and this is where gains level out, though we continue to gain daylight, and it's rather rapidly, especially the farther north you go. So northern cities still get about 90 to 100 minutes of daylight, where southern cities, all the way down to the Mexico border, still about 70 minutes. And the total from December December 1st through March 31st. Let's break it down. Seattle and Spokane over 4 hours of daylight, whereas Portland and Boise just close to 3.5 hours, but getting closer and closer to the 4 hours of daylight. So again, this is from December 1st through March 31st. Let's take you to California, close to 3 hours of daylight. San Diego, just less than 2.5 hours of daylight. Phoenix and Denver, just between 2 and 3 hours. So this is essentially, it's all about Earth's tilt. The higher latitudes get more dramatic swings, long summer evenings, but dark winter afternoons. So the good news with all of this, we're all gaining daylight every day through late June. Spring is coming, but for some of you, it's going to get there faster. Do your allergies act up this time of year? Well, you're not a Grinch, but something about the holidays could be making you pretty miserable. Unpacking holiday decorations and setting up a Christmas tree can be festive, but if you're feeling like you do during spring and fall, the allergy seasons, there's a reason why. Mandy Gaither explains why you may be allergic to the holidays.
From dusty decor to your Christmas tree, if the holidays have you sneezing, you're not alone.
A lot of people have the predominant symptoms in the spring and summer and fall, but there are some people that continue to have symptoms or maybe even have worsened symptoms when they start to get that tree out.
Dr. Chris Brooks with the Ohio State University Wexner Medical Center says if your allergies are acting up around live Christmas trees, it's not from pollen.
When trees are cut down, brought to the house, and our indoor environment, which can be warmer and more humid than the outdoor environment, there can be molds that can grow.
As for artificial trees that have been stored, Brooks says those can not only expose you to mold, but also to dust mites, pet dander, and critter droppings, which can bother the noses and lungs of even folks who aren't allergic.
If you're allergic to mold, maybe not doing a live tree. Symptoms that patients get with non-live trees might be a little bit easier to prevent, because if you're able to clean off all that dust off that tree, that might help prevent symptoms.
When unpacking holiday decor, if the boxes look dusty, Brooks says having a mask on can prevent irritants from getting in your nose. He says properly storing that holiday decor can also help prevent future problems.
Mold thrives in more humid environments, so making sure there's not moisture getting into wherever it's being stored.
For Health Minute, I'm Mandy Gaither.
That will do it for our special Winter Out West. We want to thank you so much for joining us. I'm meteorologist Ashley Ruiz. Happy holidays.